Applications of Integration, Volume by Slicing, Part 2. In Part 1, we said that the volume of a disk is pi r squared times the width of the disk, which is dx. Now, these disks are very thin, and so we said dx is a very small number. Now, the radius is your function f. So the volume of the disk is pi times f of x, quantity squared, times dx. Adding up all these disks, you get the volume of the entire solid. Here in Part 2, we're going to do a more complex situation. Let R be the region bounded by the curves of f and g, where x runs between 0 and 1. First, we need to determine the region. So spend a minute figuring out what the region looks like. After you've done that, it's time to find the volume of the solid when the region R is revolved about the x-axis. If we slice the solid, each cross section is a washer. Notice that the outer function is f and the inner function is g. So the outer radius is f and the inner radius is g. The area of the washer is pi times the square of the outer radius minus pi times the square of the inner radius. So what you're doing is you're just going area of the large circle minus area of the smaller circle. And that gives you the area of the washer. Take that area and multiply it by dx, and you get the volume of the cross section. Then, if you add up all the disks, if you add up all the washers, then you get the volume of the entire solid. In our example, x is running from 0 to 1. F is the square root of x, and g is x squared. So set up your integral, and this is what you get. We need to simplify this. So ask yourself, square root of x squared, what's that? X squared squared, what's that? After you've simplified, you're ready to integrate. And then evaluate. When the dust settles, you get 3/10 pi cubic units. Suppose we would like to revolve a region about the y-axis. To do that, we need to reverse the roles of x and y and have x written as a function of y. In that case, the region is between the outer function p and the inner function q, and y runs between c and d. The resultant volume is then given by this expression. Let's do an example. Let R be the region in the first quadrant bounded by the graphs of the functions y equals x to the 1/3 and y equals 1/4 of x. Find the volume of the solid of revolution obtained by revolving R about the y-axis. Alright, so our first job is going to be to determine the region R. That's going to take you a minute, so you might have to turn off the video and then come back. Alright, now once you have found the region, it should look like this. In the first quadrant, the graphs intersect when x equals 8 and y equals 2. As I said, to revolve about the y-axis, we need to reverse the roles of x and y. So we need to write x as a function of y. To do that, you take the two functions and you just solve for x. So do that, please. If y equals x to the 1/3, then x equals y to the 3rd. If y equals 1/4 of x, then x equals 4y. So then we rewrite our graph in this way. We instead of x going from 0 to 8, notice that y is going from 0 to 2. And then instead of the functions that we now have new functions, x written as a function of y. We have, as I said, we have each curve written with x as a function of y. The outer function is x equals 4y. Your inner function is x equals y to the 3. Y runs from 0 to 2. Now, let's revolve this region about the y-axis. We've done all our prep work. Let's do the revolution. And then set up the integral. Remember which one's your outer and which one's your inner. How'd you do? Once you do the setup, it's you simplify and integrate. So let's do that. First, let's simplify. After you simplify, integrate and evaluate. When the dust settles, you get 512 divided by 21 times pi, and remember it's a volume, so cubic units. Take care, and I'll see you in the next section.